All right. A warm welcome to you again today. So we're gonna be doing vertical projectile motion, but then um, we're gonna be focusing on the problems involving one object and then problems involving two objects, and then we're only focusing on the calculations part of things. Then in our next lesson, we'll then be talking about how to deal with what do you call graphs, right? We'll be talking about the graphs. So right now we're gonna be talking about the calculations. Now you might want to have the formulas handy when you're going to be working with these things. So remember, the first formula is this one: Vf is equals to Vi plus a change in t. Then you have Vf squared is equals to Vi squared plus 2a change in y. Then you're gonna have change in x is equals to Vi change in t plus half a change in t squared, and then you're gonna have change in x is equals to Vi plus Vf divided by 2 multiplied by change in t. So those are the formulas that you're going to need to answer these questions. The first question says a ball of mass 0.5 kg. So you might want to highlight that ball of mass 0.5 kg is dropped onto a hard floor from a height of 1.5. Okay, so that is from a height of 1.5 meters, rebounds vertically up to a height of 1.40. So this ball here is dropped and then it rebounds back to that height. Okay, so it is dropped here and then it rebounds back. So one thing you're gonna want to do when you're working with vertical projectile motion to be able to master it is you must work in sections. So we're going to name this one section A, segments I mean. So this is A, this is the start of the motion, and then B is when it reaches the ground, and then from B to C it's when it moves from the ground. But here I'm gonna put B prime. Why I'm gonna put B prime is because it is still on the ground, but I want to focus on these two parts. Okay, I'm gonna show you in a second why do I have to have B prime. Okay, but then A to B, we can even write it here just so we know that A to B is from when it was dropped, from being dropped to the ground. Okay, from being dropped to the ground. And then we'll want to say B prime to C, this is from the ground. Okay, from the ground to the height. Okay, to the height. So we're gonna have those sections of ours that we're going to be using. Okay, so now the first question says explain. Okay, they say here the ball is considered as a projectile. What is a projectile, guys? Okay, the first question is that what is a projectile? If you remember from the definitions, is that a projectile is an object which has been given an initial velocity and upon which the only force acting is the force of gravity. So that is what you probably want to write there. So that is a projectile. Okay, an object which has been given an initial velocity and upon which the only force acting is the force of gravity. So this is the definition there. Actually it's 3.1. For some reason I wrote 3.2, but that is actually 3.1. 3.2 now says calculate the speed of the ball when it makes contact with the floor after it has been dropped. Okay, we need the speed of the ball, meaning we're talking about velocity, when it makes contact with the floor, meaning it is on the ground. Okay, after it has been dropped. So which segment are we working with? Is it A, B, or B prime and C? It's actually A, B, isn't it? Yes, because it is from the moment it was dropped to when it reaches the ground. So why are you gonna call them A, B and the likes? This is because so that you can differentiate between your initial and your final. So if we're looking from A to B, our initial velocity is gonna be here. Okay, they said the ball is dropped. Whenever something is dropped, it means the initial velocity is 0 meters per second, and then it reaches B. We do not know the final velocity. Okay, this we do not know. However, what we do know is that acceleration is gonna be 9,8 meters per second squared. But then also you must choose your direction so that your calculations are correct. Okay, do we know the height? This is given as the height. Okay, so we also know that the displacement is 1,5 meters. Okay, 1,5 meters. This is all of the information about A to B. So we have more than enough information to calculate what they want. They want VF, which is the speed at which the ball reaches the ground. Okay, so you go to the formulas here, you check the formula with VF because you're looking for VF. This has VF, this has VF, and also this one has VF. This does not have VF, so we're probably gonna put an X to say we're not gonna use this formula. Now we have initial velocity, right? We have initial velocity, and then we also have initial velocity, and then we have distance, right? Which is, oh, why did I write? I don't know, guys. I really like changing X, and I don't understand why. It's changing Y there, because we are talking about the vertical direction. So you probably wanna write a change in Y here and then change in Y. Okay, so sorry for that. So the change in Y, it is there. Okay, so this one doesn't really have change in Y, but this one also has change in Y. And then do we know the time? Because this one is talking about time, but let's say acceleration, we know it, right? We know acceleration. Do we have the acceleration here? No, we don't. So that leaves us with only one formula. That is how you choose your formula. So we're gonna go through that just one more time, just so that you know how to choose the formula. So let me also in the meantime fix this one, right? It should be changing Y there. Should be changing Y. It should be changing Y. So let's start. We're looking from A to B. We know the initial velocity is 0, so we tick the formulas with initial velocity. And then we are looking for the final velocity, so we tick the formulas with final velocity. But this one doesn't have final velocity. This one doesn't have final velocity, so it's already out. And then we check the formulas with change in Y. This doesn't have change in Y, so it's already out. But this one has change in Y. This one has change in Y. Acceleration is that. Do we have acceleration here? We have, but here we don't. So that means we are left with only one formula, and that is the one that we are going to use. So now that we know the formula we're going to use for 3.2, you would write that VF squared is equals to VI squared plus 2A change in Y. Now the final velocity is really what we are looking for, so I'm just gonna say VF squared. VI, we know that is 0, but before you do this, just make sure to choose your direction. So I'm just gonna choose up as positive. Okay, you're more than welcome to choose down as positive, but I'm gonna choose up as positive. So acceleration is down, so I'm gonna write negative 9,8, and then change in Y is down because the object is going down, so you want to put that as negative 1,5. Please guys, this is a vector, it's displacement, so you must consider where the object is going. If the object is going down and you chose down to be positive, then the change in Y will be positive. But if the object is going down, as in this case, but you chose up to be positive, then your change in Y must be negative. Please just take note of that. Okay, and you will see that in most cases that I'm going to do with you guys, in most of the questions, I like choosing up as positive. It just makes much more sense. Right, so here you can now choose calculate VF, right? You're just gonna put square root of the answer there. Square root of the answer there. You got negative 9,8, you got negative 1,5. So what does that give you in your calculator? So the answer will be 5,42 meters per second, and you get the answer as positive. But actually, mathematically, when you put a root sign, remember you put plus or minus. So this is plus or minus that, but the answer is going to be the negative one. Okay, so it's gonna be negative 5,42 meters per second. Why am I saying it's gonna be negative? Well, remember we said up is positive, and the object from A to B is going down, so we should have negative there since it is going down. Okay, so please, whenever you put a root, especially on this equation, you put plus or minus, then you choose the correct one. Okay, so that is great. Hope we're happy about that. Now we can put that our final velocity was 5,42, but we know that it is moving down there. Okay, so that is velocity at B. Now 3.3 then says, write down the magnitude and direction of the acceleration of the ball while moving upwards after it has bounced from the floor. So they want to know now, as it is moving from B prime to C, meaning as it is going up, what is the magnitude and direction of the acceleration of the ball while moving there? This is a common question that they like asking, and sometimes they ask it in different ways. But guys, I need you to know that acceleration will never change. Acceleration in vertical projectile will always be 9,8 meters per second squared downwards. Okay, it will always be like this, whether the object is on the maximum height, whether the object is going up, whether the object is going down. Please know that acceleration will always be 9,8 meters per second squared downwards. Okay, so this is a question that they like a lot. Just take note of that. And then 3.4, it says, is the collision of the ball with the floor elastic or inelastic? The ball moved from A to B, and then B to C, it went to 1.4. What do you think would be the answer? Do you think this is an elastic or an inelastic collision? Great, it is an inelastic collision, mainly because it didn't go to the same height as the previous one. Remember, it was 1,5, right? But now it didn't move to the same 1,5. Now it only moved to 1,4 as its maximum height. So that means that it lost energy, and if it lost kinetic energy, that means that that collision will be inelastic. Okay, then 3.5 says, calculate the change in kinetic energy of the ball due to the collision with the floor. Now that's a nice question, because we just said it right now that it lost some of the kinetic energy. Now when you want to calculate the change in kinetic energy due to the collision, you have to understand what are we talking about when we talk about kinetic energy. Okay, so so let me just write my 3.3 here. Good people, remember that kinetic energy, right? Also it's 3.5. Sorry, kinetic energy is half mv squared. So when you say change in kinetic energy, we're gonna be saying kinetic energy final minus kinetic energy initial, which means half mv squared final minus half mv squared initial. Okay, so what is the final velocity? So we'll need to know what is the final velocity. They said it rebounds vertically to that height, which means that was the maximum height. Remember guys, at the maximum height the velocity is always 0, right? It is 0 meters per second. Okay, so what is the velocity at B prime? What would be the velocity at B prime? Okay, so what you wanna do there is that you need to look at you need to substitute the final velocity, you need to substitute the initial. Actually, we were given the mass of the object. From the question, it said that a ball of mass 0,5 kg. Okay, it said 0,5 kg. So we are given the mass of the object. That is why here you would say you'd substitute that you have 0,5 kg, right? So you're gonna have half 0,5. Now what will be the final velocity? Remember, it's gonna be 0, because at C there is the maximum height, and the maximum height, the velocity at the maximum height is always 0. And then you say half, the mass is still 0.5. However, the initial velocity now, remember that the ball reached the ground with 5.42 meters per second. If it is an elastic collision, okay, if it is an elastic collision, if it is an elastic, right, this one, if it is an elastic collision, because the ball does not lose energy, the velocity it reaches with is the same velocity that it's going to go up with if it is an elastic collision. But if it is an inelastic collision, students, it's going to be, the velocity is going to decrease. So that means we actually have to find first the velocity at which this thing is going to go up with. Okay, so that means we must use our formulas to find the velocity at which that ball is going to go up with, because it is an inelastic collision. So for elastic, the velocity that you reach the ground with is the very same velocity that you're gonna leave the ground with. But if it is an inelastic, those velocities won't be the same. Okay, so just please remember that for me. So now how are we gonna calculate the velocity at B prime? We are simply going to say the information we have is that we have the velocity, we also have change in y as 1.4 meters, and then we know the acceleration. This one, never make a mistake, we know the acceleration is 9.8. So good people, we are going to choose the formula now we're going to use to calculate the velocity here at B prime. If it is an inelastic collision, you need to find out that velocity. Okay, so to calculate that, we will say the information we have final velocity here. Remember, this is VF. We're looking for V initial. So VF and V initial are in these formulas. So I'm just going to make some small ticks. Here we don't have VF, isn't it? So we're not going to use this one. Here we do have VF with V initial. And then change in Y. Here don't have change in Y, but we do have it here. We do have it there. And then acceleration, we know acceleration, but here we don't have acceleration. So still the formula we're gonna use is the one above. So when we use that formula, what are we gonna say? We are going to say VF squared is equals to VI squared plus 2a change in y. Now the final velocity is 0, guys, but then we do not know the initial velocity. And then we say 2, the acceleration, remember up is positive, acceleration is always downwards, so we put it as 9.8. But the change in y now, since the object is going up from B prime to C, so we have to use 1.4 and positive. It has to be positive because the ball is going up from B prime to C. So do you see that if you have drawn some segments, like labeled your motion, it's going to be easy to answer questions. So now you're gonna solve for VI, guys. So to solve for that, simply gonna maybe take this whole part to the other side, I think, but you can just get your VI there for me. Remember, it's gonna be plus or minus, but we're gonna take the positive one because the object is going up and up is positive. So what would be our VI there? So if you put that in your calculator, you get 5.2383. You want to make sure that it's rounded off to 4 decimal digits because now it's not the final answer yet. So it's gonna be 5.2383 meters per second. Remember, you do that by finding the answer here, then that answer you take it to the left, it's gonna become positive, then you see square root of that answer. So what we need to understand here, guys, is that when you check the motion of the object, you have two parts of the motion, right? You have the motion whereby when the object was moving from here, right, all the way down. So here's a ball, right? It's like it moves like this. It goes here, then it moves down, and then it bounces up. So it moved from a height of 1.5. Okay, it started with 0 meters per second, and then it gained velocity. Remember, when an object is going down, it gains velocity, meaning its velocity increases downwards. You understand? So here is the velocity. It increases, it increases, it increases, it increases until it reaches at the ground at B. And what is the velocity at B? It's 5,42. We just put in negative to indicate that it is 5,42 downwards, because velocity is a vector. You need to include direction. So here's the object. It started from 0, then, and one thing you must know is that any object that will be going down is going to gain velocity, meaning it's going to increase the speed due to the force of gravity pulling it down. Any object that goes down, you can even write that down, okay? Any object that goes down in projectile motion is going to increase its speed, while any object that goes up is going to decrease its speed. That is one thing you must know. The reason why here we are moving from 0 to 5,42 is because the object increased the speed, then it reaches the ground. Fine. If it reached the ground at 5,42 meters per second, how much velocity did it leave the ground with? Because we don't know that velocity, but it is velocity at B prime. But one thing we must understand is that, or rather one thing we know is that when it goes back up, it's going to lose velocity, lose energy, and then now the velocity is going to be 0 at its maximum height. So 1,4 now is the new maximum height, you see. So that means it lost energy from B prime to C. Now we want to know how much velocity did it move up with. You understand? We want to know how much energy of velocity did it move up with. For us to find out that velocity, that is why here we calculated, okay? That is why here we used this formula here and said the final velocity is 0. Remember, this is velocity where? That is velocity at C here. This one is velocity at C. While this initial velocity is the velocity at what? At B prime. Okay? This is the velocity at B prime. This is velocity at C. So we know that it's 1,4, right? In terms of the height, it's gonna go and then the likes. So here we solve and then we get the velocity at what? We get the velocity at B prime, which gives us the velocity that the ball left the ground with. So it means the ball left the ground with 5,42 meters per second. Okay, so the ball left the ground with 5,42 meters per second, and then it went up to C. So when you look at these two velocities, they are not the same. This one is 5,42, this one is 5,24. This tells you that this velocity here is bigger compared to the velocity here. Don't look at the sign, because the sign only indicates direction. The value itself, 5,42, means that the velocity that the ball hit the ground with is much more than the velocity that the ball left the ground with, because the ball left the ground with 5,24 meters per second. Okay, so now it touching the ground, the ball touching the ground, we call it a collision, because that is a contact between two objects. So that means we call it a collision. So we can say 5,42 meters per second is the velocity before the ball collided with the ground, while 5,24 is the velocity after the ball collided with the ground. Okay, so these two velocities, we use them to calculate the change in kinetic energy, to find out either the kinetic energy that was lost during the collision or the kinetic energy that was gained during the collision. If this 5,24 was higher, if it was maybe 5,7, the ball would have gained more kinetic energy, and its height was going to be, it was going to reach a greater height. Maybe it would have ended up somewhere here. It means it would have gained kinetic energy. But in most cases, it's going to, but the two cases we're going to have is that it's either going to lose kinetic energy, or the kinetic energy is not going to change. Those mostly are our two cases. So here it lost kinetic energy because it went to a less height. But if it had went to the same height, the VI here was supposed to also be 5,42, and that would have been called an elastic collision. But since our collision here is inelastic, the ball reached only 1,4, which is a less height, which means it went up with a less velocity. So we want to know what happened in terms of kinetic energy. Hence, we want to calculate the change in kinetic energy. So to calculate change in kinetic energy, you say the final kinetic energy, which is kinetic energy after collision, and then minus the initial kinetic energy, which is kinetic energy before the collision. So you say half mv squared. So that is why here we're gonna have, that is why here we calculated that change in kinetic energy like this. After the collision, the velocity was 5,23, but before the collision, the I tells you that before the collision, which is initial, the velocity was 5,42. This is after the collision, this is before the collision, meaning before it touched the ground, after it touched the ground. So we use those two velocities to then get an answer of negative 0,49, which tells us this negative here, the one you see here, tells us that the ball lost energy. Okay, and which makes sense. So it lost 0,49 joules, which makes sense because it only went up to 1,4 meters instead of the 1,5 meters it was dropped from. Okay, so here's the next question, right? We are told that a boy is standing on the edge of a cliff, right? And projects a ball vertically up. So the ball is thrown up at a speed of 20. So we already know, I'm just gonna already call this A, which is when the ball was here. On its return, the ball passes the boy and reaches the ground. So this means this ball is probably gonna be moving like this and then go back down. This is more like the position versus time of it, but remember I said we'll look at graphs. So here it's B, and then here it is C, and then I'll just call this one D. Okay, it reaches the bottom of the cliff 6 seconds after it was projected. So it means when you look at information from A to D, we already know the time, that the change in time was how much? Was 6 seconds. And we also have to know that the velocity at A was 20 meters per second, by the way, but we do not know the velocity at D, right? What is the distance? We don't even know the distance there, or but we do know that the acceleration was 9,8 meters per second squared. This is only the information for A to D. Okay. 3.1, define the term free fall. So what is free fall, guys? Please remember that this is motion. Free fall is motion. A projectile is an object. So free fall is a motion under the influence of gravitational force only. Okay, motion under the influence of gravitational force only. Okay, motion under the influence of gravitational force and only. Sorry for the handwriting. 3.2 says give the magnitude and direction of the acceleration of the ball the moment it reaches the maximum height. This is exactly the same question I told you that they like asking in different ways. In here they said write down the magnitude and direction of the acceleration of the ball while moving up. Right now here they're saying write down the magnitude and direction of the acceleration once it reaches maximum height. The answer is always the same, that acceleration is always 9,8 meters per second squared, and the direction is always downwards. Okay, so you must understand that acceleration does not change if something is under free fall. Now 3.3, calculate the time taken by the ball to pass the boy on its way down. It's becoming a tongue twister, guys. By the ball to pass the boy. Wow, so many B's there. Okay, so we need that time, by the way, taken by the ball to pass the boy, meaning we need to know how long did it take for it to reach C, because that is when it is passing the boy at C, isn't it? At C there, that is when it is passing the boy on its way down. So we need to know what is the time from A to C. Well, that shouldn't be much of a hassle. That means you just have to shift your focus to A to C and list the information you have from A to C. So we do know that the velocity at A is how much? Is 20 meters per second. We do know that the acceleration is 9,8 meters per second squared. Now at C there, we don't know anything, right? But we do know that the velocity at C, by the way, is gonna be negative 20 meters per second due to time symmetry. The velocity that when like if an object is like this, if we can call this A, B, B, and then maybe maximum C, and then here D, and then E. If this was at the hand, right, on the hand, it's gonna go up. The velocity here at A is the same as at E. The velocity at B is the same as at D. You understand me? The velocity here is the same as there, here is the same as there, just that those velocities are gonna have a different sign. So if here it went with 5 meters per second, here it's gonna come back at negative 5 meters per second once it reaches maximum height and comes back. Okay, it works in this way. Okay, but that is one way of doing this problem. You can look at A to C, or if you want, you can also look at A to B, because A to B seems to have more information. Let me show you. Velocity at A will be 20 meters per second, right? Velocity at B, what will be the velocity? Remember, this one is going to be 0 because it is at maximum height. Then what is going to be the acceleration? Remember, acceleration is 9,8 meters per second squared. And then remember that you're going to be looking at the change in time from A to B. Remember, once you get that time, you just multiply it by 2. It's going to be the time from A to C, because the time it takes to go to B is the same time that it's going to take to go to C. So the time at AB is the same as the time at BC. So if you want to check the time at AC, it's going to be it's going to be the time at AB times 2. I hope you understand me. So I'm probably going to use this one because it has more information. Guys, I don't know which one you chose. So velocity at A, I'll take it as initial. This one I'll take it as final. So it means I take the formulas with final, right? This one doesn't have final, so it's out. Initial, and then initial, and then time. So this is time. This doesn't have time, it's out, but this is time. Acceleration. This doesn't have acceleration, but this one is acceleration. So I'm left with one formula, and that's what I'm gonna use. So for 3.3 there, I'm gonna use VF is equals to VI plus a change in t, but I'm gonna choose upwards to be positive. I like choosing upwards to be positive. So now the final velocity is what? 0. The initial is because it's going up, it's gonna be 20. The acceleration is gonna be negative 9,8, and then I'm looking for change in t. So I'm gonna have 9,8 change in t is equals to 20. So the change in time there, so it will be 20 divided by 9,8, right? 20 divided by 9,8, so that gives me 2,0408. So I take 4 digits, okay? 0408. So it's 2,0408 seconds. Then therefore, since this is the time from A to B, now the time from A to C is simply gonna be that. So it means total time, or rather time taken is then gonna be that 2,0408 multiplied by 2. Then what are we gonna add? get 2,04 we multiply that by 2, then we get 4,08 seconds. So the answer is going to be 4,08 seconds. Okay, I hope that was clear. Then now so we need to update our information. So here at B we now know that this was 2,04, approximately 2,04, and then here we know that the change in time was 4,08. Okay, so this is all the new information that we have about that ball. Calculate, the last question says calculate the height of the ball above the ground 2,8 seconds after it is released. Wow, that is a beautiful question. So what are we gonna do there? So what we will probably want to do there, right, I'm just gonna take this away because we already calculated that, and now we're gonna deal with that next question there. So for 3.4 we need the height of the ball above the ground 2,8 seconds after it is released. Good people, read the question carefully. The height of the ball above the ground. You must be careful. It says above the ground 2,8 seconds after it is released. Above the ground. So for you to get this question correct, you're gonna have to do a bit of few things first. Number one, you wanna get to know what is the change in y. You want to know what is the height here from here to there. You want to know what is the height here. Once you have the height there, right, once you have the height there, then you can then work forward, you understand. But I think the most problematic thing there is that we do not know the velocity that the ball will reach the ground with. We don't know the velocity that the ball will reach the ground with. So you can use the formula. So this is 3.4. Just write 3.4. So let's find out first how far it has traveled 2,8 seconds after it was released. So that means you're talking about from A to somewhere, I don't know. But we already know that the initial velocity is going to be 20. So we're going to need a formula with initial velocity, of course. But then we're looking for the time. We have the time. So we're going to need a formula with time. This doesn't have time. This has time. And that has time. Then we know acceleration. This has acceleration. This doesn't have acceleration. But this one has acceleration, so we are left with two formulas, and then to choose from there, we don't know the final velocity. We are looking for the height, isn't it? So this one is not gonna work, but we're gonna use change in y equals to vi change in t plus half a change in t squared. Remember, up is still positive, so we're gonna get our height here. The initial velocity is 20, so up is positive. I'm gonna put that as positive 20. We need after 2,8 seconds, right? Then half a is gonna be 9,8, but we're gonna put it as negative because acceleration always goes down. And then 2,8 and then all squared. So what do you get as the change in height? What is the displacement there? So we get 17,584 meters, and it is positive because the object is going up. So that means, good people, since it is positive, that tells you that we are looking at somewhere from here to maybe, I don't know, we don't wanna, we just wanna maybe like assume that it will be somewhere there, but it's not really assuming, it's just an educated guess. 17,584 will be somewhere there, meters, but it is up. We just know that it's up because it's positive here. Okay, so we do know that it is up. If it was negative, then we would know that actually it was on its way down there, so it would be somewhere down here because it would be negative. but it's positive, so it means it's up. Now we need to know now what is the height, right, since this is 17,584, this is the height above from where it above the cliff. Okay, this is above the cliff. Okay, this is above the cliff. Now but the question wants to know above the ground. So since you have the height above the cliff, if you can add also the height of the cliff, then you're gonna have your answer as the height above the ground. So we need to know how tall is this cliff. And for us to know that, we have to focus on A and D. Okay, so meaning you have to focus on A and D. On A and D, we have information we listed already. We know that the total time that it took, it was 6 seconds. And then we know that the initial velocity was that. We do not know the final, but then we can work our way through. So on A to D, I can say I have time. So I'm going to probably remove these other ones, right? Remember, you wanna like do that with a pencil, these things, so that it's easy to rub, and then you can quickly work on the next question when you are writing an exam or when you are writing a test. Okay, so time, this has time, this has time, and then this has time, but this doesn't have. We don't have the final velocity, we only have initial, so probably gonna need this one, not this one with final velocity, not this one. So already I have my equation as only that one. So I'm gonna use change in y is equals to v initial change in t plus half a change in t squared. So this is going to give me the change in height, meaning it's gonna give me the height of the cliff. So the initial velocity is 20, right? The time taken is 6 seconds. Remember, that is the total time from A to D. Remember, displacement means is the measurement from your initial to your final. So remember, I'm only writing it this way, guys, because just for you to observe. But in reality, remember, that ball is moving like this. It moves from here, it goes up, and then it comes back down. You understand? So that is why here the change in y is going to be, this is your A and then D. So the change in y is going to be the height of the cliff. Okay, so we have half, and then you're going to have negative 9,8, and then the time is going to be 6 seconds squared. So what do you get as the answer there as your change in y, meaning the height of the cliff? So you get negative 56,4, negative 56,4 meters. Good people, why is it negative? Remember, down is negative. That means from A to D, I agree it was going down here. From A to D, it was going down. That's why here we get as negative 56,4. Okay, we get it as the negative just means it was going down, but the height from A to D there is 56,4. That is the height of the cliff. So since height is positive, because height is positive, this is displacement, good people. It's not really the height. Like, you have to understand that once you are talking about direction, you are referring to displacement, but in terms of height, it's just simply positive 56,4. So therefore, above the ground, right, above the ground, it will be that height above the ground. So let me write that height above the ground would be the height of the cliff, which is 56,4, the height of the cliff, which is 56,4, plus the 17,584, which is the height above the cliff. Then those two things are gonna give you the height above the ground. So what do you get as the answer there for the height above the ground? 56,4 plus 17,584. So you get the answer is 73. Oh, it's what, 73. Apparently that thing, when it disappears like that, I can't see it anymore. 73 I meant 73 comma, yeah, comma, it's what, 9, yeah, 98 meters. I think that is the one there. Okay guys, so that is how we do that question. Okay, I hope that it was clear, and the next time we're gonna be moving to 2 objects, and then we're gonna talk about the graphs. Okay, yeah, any question from there?